Good morning. My name is Amber Rogers, and today I'll be presenting a bit about the state of affairs of physiologically based pharmacokinetic PBPK models in pregnancy. The majority of women in the US report having to take at least one medication throughout their pregnancy. These medications may have been prescribed or bought over the counter to help manage any of the listed conditions that may present prior to becoming pregnant or develop throughout the pregnancy and may persist into the postpartum period. However, the majority of women go untreated throughout their pregnancy as a result of the lack of guidelines to really ensure safety and efficacy for them. This is a particular concern as the maternal age within the US continues to increase, meaning that women are more likely to have to take a medication because they will have a pre-existing condition or be at an increased risk for developing a gestational condition. There are many different changes that occur throughout a pregnancy that further complicates the maternal age concern. For example, each of the major organ systems are affected, the cardiac output is increased, glomerular filtration rate is increased, tissue volume is increased, and most interestingly to me is that there is a change in the metabolic enzyme activity. Altogether, these different changes can affect a drug's absorption, distribution, metabolism, and elimination, and has created this pressing need to understand the changes that occur throughout a pregnancy and their potential to impact PK. This is important to ensure drug safety and efficacy for these women. So how can we really assess and ensure drug safety and efficacy? Physiologically based pharmacokinetic PBPK models have been used extensively to predict drug disposition within the different tissues or within the system as a whole. And they have become very popular lately for use in special populations such as pediatrics and pregnant women, particularly for pregnant women because of the inclusion of this fetal placental unit. A lot of the concern that women have when they have to take medication is, will their baby be affected? The inclusion of this fetal placental unit allows for the estimation of what drug gets to that child and its ability to influence their development. However, for the mother, we can look at the different organ systems and the different tissues of interest to ensure that she's reaching the therapeutic levels of that drug as desired. So these models work by combining what is known about the drug and what is known about the system. For example, the protein binding capacity of that drug and what are the protein levels within the body or system within the population. And together you can go ahead and combine these to create a prediction of the drug concentration over time, from which we can extrapolate key pharmacokinetic parameters such as Cmax, AUC, Tmax, and half-life that can inform what is the drug concentration level, whether it's hitting that therapeutic level, whether it's a toxic level, or whether it's below the therapeutic level. So with that, we can really decide whether or not dose adjustments will be needed to ensure that a woman can be treated safely and effectively. So for this mini project, what I've done was evaluate the current PBPK models that have been used in pregnancy. Starting out with the mPrint Silver database, I went ahead and looked at all of the PBPK studies that were done in a pregnant population, and we found that there were about 50 different articles that exist for this population, for this study. PBPK models, from these PBPK models and studies, what I did was pull out all of the drugs and went ahead and grouped them by the different classes. And we found that the majority of drugs that were in these studies were anti-HIV or antiretroviral drugs. And this is really no surprise, considering that the FDA has really made a push for the use of these models to ensure limited mother-to-baby transmission in utero of HIV. Because we're interested in the metabolic enzyme changes that occur throughout pregnancy, I went ahead and looked next at what were the different metabolizing enzyme substrates that were included in the study. And we found that the majority of them were CYP3A substrates. And because of the CYP3A metabolizing, and because of CYP3A substrates really being the most targeted on the market, the pharmaceutical market, we went ahead and filtered the data set out to focus only on the CYP3A substrates. So the first thing we did really after that was look at how the different trimesters of pregnancy were being represented in these models and whether or not the postpartum was included. These are two very key pieces of information, considering that there are changes that occur throughout the entire pregnancy and even in the postpartum period, and medications may be needed at the onset of pregnancy and even into the postpartum. And what we found was that the third trimester was the most studied trimester throughout the study. There were a few that covered the entire pregnancy from onset to delivery, but very few even included the postpartum period. Next up, we looked more closely at the metabolic enzyme activity throughout the different studies, and we found that for the different platforms that were used to model these studies and in the different articles, we had differences in the reported CYP3A4 activity for each of the different studies. This became very interesting, very important to note, because going forward or using these models, if each of these have a different reported activity level, understanding how a CYP3A substrate actually is changed or metabolized throughout pregnancy, there was going to be some form of a misunderstanding. So in conclusion, the use of PBPK models in pregnancy is increasing. And with this increase, there are many different things that must be considered to ensure that the models and their predictions can be actually used. For example, the changes in reported CYP3A4 activity must be carefully considered. And the trimester data is also something that must be carefully considered, because these models currently underpredict or overpredict exposure in pregnant women. And to be able to manage this effectively, we need to consider all of these. And I just wanted to go ahead and thank my mentor and all of the individuals listed on the screen. Thank you.